Hi, we're here to talk about the atom today. This in particular focuses on the Edexcel additional chemistry specification, although it can be applied to the other exam boards.
The next thing we need to know about are isotopes. Isotopes are different atoms of an element with the same number of protons and electrons but different number of neutrons.
So, first off, what does an atom look like? An atom has a nucleus at its centre. This contains protons and neutrons. We'll talk about these a little bit more later on. We also then have electrons filling shells around the nucleus.
Both protons and neutrons have a relative mass of 1. Electrons, in comparison, are exceptionally tiny. Their mass is approximately 1/2000th of the mass of a proton or a neutron.
When we draw an atom, we don't usually draw the nucleus. So, for example, if we start off by drawing hydrogen, which has 1 electron, we put the symbol for hydrogen, which is a H, in the centre, and then we draw our shell around the outside.
So, how do we fill up the shells? Well, for additional chemistry, you only need to know up to the first 20 elements. That means we've got 20 electrons in which we need to put into shells. Our electron configurations are as follows: 2 in the first shell, 8 in the second shell, 8 in the third shell, although if you go above 20 electrons it can hold more than 8, and then to get 22 in the last shell, and again that can hold more than 2 electrons. This is known as a written electronic configuration. We can also draw our electronic configuration. If we take calcium, for example, which is our 20th element and therefore will have 20 electrons, our first shell holds 2 electrons. Our second shell holds 8 electrons. We put those in as if we're putting them every 15 minutes of a clock. 1, 2, 3, 4, 5, 6, 7, 8. Our third shell also contains 8 electrons. And our final outer shell for our last 2 electrons forms 20. Now, electrons are negative. It doesn't matter about where you draw them so much in additional chemistry. However, if you think about the fact that they will repel, you can draw them opposite sides of your shell. In your exam, you can also draw your electrons as crosses instead of dots. The next thing that we need to know about are isotopes. Isotopes are atoms of the same element that have the same number of protons and electrons, but a different number of neutrons. Hopefully you'll be able to think about why this is important from the earlier part of the video. Now, we said before that protons and neutrons both had a mass of 1. Electrons have a very, very, very small mass in comparison. Now, if we have atoms with different numbers of neutrons, it means that we have atoms with different masses. Let's take carbon, for example. Carbon has 6 protons and most of the time has 6 neutrons and has a mass of 12. If you look at a very precise periodic table, you will see the mass isn't exactly 12. It's very close to 12, but it's not exactly. This is because we also have carbon 13 and carbon 14. Carbon 12 has 6 neutrons. Carbon 13 has 7 neutrons. And carbon 14 has 8 neutrons. All 3 of these are isotopes of carbon. If we have a percentage abundance of each of these types of carbon, then we can work out the relative atomic mass of carbon. As I say, the relative atomic mass is very, very close to 12. That means that most of the carbon in our atmosphere is carbon 12 rather than carbon 13 or carbon 14. but the other types of carbon are extremely useful. For example, carbon-14 is used in carbon dating. So we mentioned a minute ago about relative atomic mass. Now, because atoms are so small, we have to measure their mass in relation to each other. So the thing that we measure it in relation to is carbon-12, which we assign a mass of 12. We can work out the relative atomic mass of different elements. Now, to do that, we need the relative abundance, which is the proportion of the different isotopes of the element in question. So, for example, 75% of all our chlorine atoms in the atmosphere are the 35 chlorine isotope. The remaining 25% are the 37 isotope. Notice that the proton number has remained the same. So to work out the relative atomic mass, we need to take the percentage of chlorine 35 and times it by the mass, which is 35. We then need to do the same thing for the percentage of chlorine 37. We then add these two values together and divide by our two percentages added together, which is 75 plus 25, which is 100. This gives us 2,625 plus 925 divided by 100, which is equivalent to 3,550 divided by 100, which gives us our 35.5, which is the value that we see for the mass of chlorine in the periodic table. This gives us a very quick pit stop into the atom. This isn't everything you need to know for topic 1 of the additional chemistry on the Edexcel scheme of work. However, it does cover a lot of the basics.